Hello students, good morning to everyone. In the previous video we already discussed about periodic law, modern periodic law and some properties of modern periodic table. Means what it contains. Yes students, in this video I am going to explain one more important concept, that is the nomenclature of elements having atomic number greater than 100. Yes, nomenclature of elements having atomic number greater than 100. ನೂರಕ್ಕಿಂತ ಹೆಚ್ಚು ಪರಮಾಣು ಸಂಖ್ಯೆ ಒಳಗೊಂಡಿರತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ಸ್ಗೆ ಹೇಗೆ ಹೆಸರು ಕೊಡ್ತಾರೆ ಅಥವಾ ಹೇಗೆ ಅವಕ್ಕೆ ಹೆಸರು ಕೊಡಬೇಕು ಅನ್ನೋದನ್ನ ಇವತ್ತಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ನೋಡೋಣ. Students, while writing the IPAC means nomenclature of elements having atomic number more than 100, first remember one chart. Means it contains some root words. In presence of a particular digit, we use one root words. So first we remember this chart, write on the board, make 3 columns. As in presence of first column, I take digit, means value, and here the name means root word name or part of the word which is used in a particular digit, and here I take abbreviation. Okay, short ಅಲ್ಲಿ ಏನು ವರ್ಡ್ ಯೂಸ್ ಮಾಡಬೇಕು ಇಲ್ಲಿ. Yes, if 0 is present and I take here 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Students, if the atomic number of element when it is greater than 100, then how you write the name of that element? See here. If the element contain 1 0 digit, then the word nil is used. Next, if 1 is present, then use the word un. If 2 is present, use by. If 3, then use try. Then 4, if it contains 4 digits, then use the word quad. If 5 is present, use the word pent. If 6 is present, x. If 7 is present, sept. Then 8, oct. 9, en means n. Students, while writing the name means nomenclature of elements which having atomic number greater than 100, then use the words nil if it contains 0, un if it contains 1, by if it contains 2. If 3 is present, then use try. If 4 is present, use quad. If 5 is present, pent. 6 hex, 7 sept, 8 oct, 9 n. En. And abbreviations for 0, it is n, it is u, and this one by means b, and 3 means t, 4 q, this is p, this is h, this is s, this is o, this is e, means first letter of the word. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. If you remember this chart, then it is very easy to write the name of a element which having atomic number more than 100. ಏನು ಈ ಒಂದು ಕಾಲಮ್ ಅನ್ನು ನೆನಪಿಡಬೇಕು. ಇದು ನಮಗೆ ಎದಕ್ಕೆ ಸಹಾಯ ಮಾಡ್ತದೆ ಅಂತಂದ್ರೆ ಯಾವ ಎಲಿಮೆಂಟ್ ಅದರ ಅಟಾಮಿಕ್ ನಂಬರ್ 100ಕ್ಕಿಂತ ಮೇಲ್ಪಟ್ಟಿರ್ತದೆ ಅದರ ಹೆಸರು ಬರೀಬೇಕು ಅಂದ್ರೆ ಈ ಚಾರ್ಟ್ ಅವಶ್ಯ ಅದ. ಎಸ್ 0 ಇದ್ದಲ್ಲಿ ಏನು ವರ್ಡ್ ಯೂಸ್ ಮಾಡಬೇಕು? ನಿಲ್ ಅಂತ ವರ್ಡ್ ಯೂಸ್ ಮಾಡಬೇಕು. 1 ಇದ್ರೆ ಅನ್ ಅಂತ ತಗೋಬೇಕು, 2 ಇದ್ರೆ ಬೈ ಅಂತ ತಗೋಬೇಕು, 3 ಇದ್ರೆ ಟ್ರೈ ಅಂತ ತಗೋಬೇಕು, 4 ಇದ್ರೆ ಕ್ವಾಡ್, 5 ಇದ್ರೆ ಪೆನ್, 6 ಇದ್ರೆ ಹೆಕ್ಸ್, 7 ಇದ್ರೆ ಸೆಪ್ಟ್ ಅಂತ ವರ್ಡ್ ಯೂಸ್ ಮಾಡ್ತಾರ, 8 ಇದ್ರೆ ಆಕ್ಟ್ ಅಂತಾರ, 9 ಇದ್ರೆ ಎನ್ ಅಂತಾರ. ಏನಿದು ಟೇಬಲ್ ಮಾಡಿಟ್ಟಿರ್ತಕ್ಕಂಥ. ಓಕೆ, ಟೇಕ್ ಸಮ್ ಎಕ್ಸಾಂಪಲ್. Write the IUPAC name of the element which having atomic number 101. 101. 101 atomic number ಇರತಕ್ಕಂಥದ್ದು ಹೆಸರು ಹೆಂಗೆ ಬರೀಬೇಕು? Students, one more important thing you remember while writing the IUPAC name of a element which having greater than atomic number greater than 100, then the name ends with IUM. While writing the name ends with IUM. It will be the helping word. ಈ ಒಂದು ಹೆಸರು ಬರೆಯುವಂತ ಸಂದರ್ಭದಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಹೆಸರು ಏನಂತ ಎಂಡ್ ಆಗಬೇಕು? IUM ಅಂತ ಎಂಡ್ ಆಗ್ತದಂತ. So now try this 101. You know students, if one digit is present, then use the part of the word un. Is it right? ಇಲ್ಲ one is ಏನಂತ ಯೂಸ್ ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳಿ ನಾನು un ಅಂತೀನಿ. ಓಕೆ, ಇಲ್ಲಿ 0 un ಒಂದು 0 ಅಂದ್ರೆ ಈಗ ನಾನು ಬರ್ತೀನಿ ಒಂದು ಇದಕ್ಕೆ ಇಲ್ಲಿ 0 ಇದ್ದಕ್ಕೆ ಕರೀತೇವೆ ನಿಲ್ ಅಂತ ಬರ್ತದೆ. ಅನ್ ನಿಲ್. ಮತ್ತೊಂದು ಏನದ 1 ಅಂದ್ರೆ ಮತ್ತೆ ಅನ್ ಅಂತ ಬರ್ತದೆ. ಓಕೆ, ಕಾಮನ್ ಆಗಿ ಹೆಸರು ends with IUM. Yes, un nil un yum. It is the IUPAC name of element which having atomic number 101. Similarly, 102 ಹೇಗೆ ಬರ್ತೀರಾ? 102 ನೋಡಿ, 1 ಇದ್ರೆ ಏನಂತ ಯೂಸ್ ಮಾಡ್ಬೇಕು ಅಂತ ಹೇಳಿರಿ? ಅನ್. ಅದನ್ನ ಬರ್ಬೋದು. 1 ಇದ್ದಕ್ಕೆ ಅನ್ ಬಂದ್ರೆ. ಓಕೆ, 0 ಇದ್ರೆ ಏನ್ ಬರೆಯಂತಾರ? ನಿಲ್ ಅಂತ ಬರೆಯಂತಾರ. 2 ಬೈ ಅಂತ ಬರೀತೇನೆ. ಸಿಮಿಲರ್ ಆಗಿ IUM ತೋರಿಸಬೇಕು. ಎಸ್, ಇಟ್ಸ್ ಓವರ್. 102 ಅನ್ ನಿಲ್ ಬಿಯಾಯಂ. ನೆಕ್ಸ್ಟ್ 103. 1 ಇದ್ರೆ ಅನ್, ನಿಲ್ 0 ಇದೆ, 3 ಇದ್ರೆ ಟ್ರೈ I. Okay, see another one important point. Here try IUM instead of double I, write only one I with M. So unil bayam. So it is correct. Unil bayam. Next 104. 1 un. 0 means nil. 4 means quad. IUM. Unil quadum. Next 5 means 105. Unil pent. IUM. ಅರ್ಥ ಆಗ್ತಾ ಇದೆ? ಇದು ಈ ಚಾರ್ಟ್ ನೆನಪಿಡಬೇಕು. ನೆಕ್ಸ್ಟ್ 106. Unil heads IUM. If 107 unil heads, 7 is word set is used. IUM is compulsory. Unil septium. Yes, 108 very important number. 108 very important. ಅದು ಯಾಕೆ ಗೊತ್ತದ ನಿಮಗೆ? un, nil, oct, ion. Un, nil, oct. Similarly, if you go from like this, next 1, 1, 1, right, or try this 1, 1, 1. One means un, another one means un, another one means un, ionium. Yes. Similarly, 118. Last one, oct, ionium, octium. Yes. Remember students, in presence of CET, one question is compulsory on this concept. Therefore, remember this chart. This is very important. The correct name of the element having atomic number 118. The question is like this in CET. The correct name of the element having atomic number 118 is octium, septium, tritium, etc. Correct answer is octium. Is it right? Yes. Okay, students. Next, another one concept: classification of elements. Classification of elements in periods. Classification of elements in periods. Students, in previous video we already know, in presence of modern periodic table, there are 7 horizontal rows are called as periods. ನಿಮಗೆ ನಾನು ಹಿಂದಿನ ಅವಧಿಯಲ್ಲಿ ಹೇಳಿದ್ದೇನೆ, ಈ ಒಂದು ಆಧುನಿಕ ಆವರ್ತಕ ಕೋಷ್ಟಕದಲ್ಲಿ 7 ಹಾರಿಜಾಂಟಲ್ ರೋಸ್ ಕಂಡು ಬರ್ತಾವ, ಅವು ನಾವು ಪೀರಿಯಡ್ಸ್ ಅಂತ ಕರೀತೇವೆ ಅಂತ ಹೇಳಿ. ಹೌದಾ? ಓಕೆ, ಈಗ ಪೀರಿಯಡ್ಸ್ ಅಲ್ಲಿ ಯಾವ ತರ ಎಲಿಮೆಂಟ್ಸ್ ಕ್ಲಾಸಿಫೈ ಆಗವ, ಭಾಗಪಟ್ಟಾವ ಅನ್ನೋದನ್ನ ನೋಡೋಣ. Students, there are 7 horizontal rows are also called as periods. In that first period, it contains 1s orbital. Students, when you observe the modern periodic table, the first period contains only 2 elements. What are those? Hydrogen and helium. Remember, first period it is one of the very short. It is one of the very short period. Very short period containing only 2 elements. Only 2 elements. What are those? Hydrogen and helium. Hydrogen and helium. This is very important. Students, remember, ಒಂದೇ ಪೀರಿಯಡ್ ಏನದಲ್ಲ, ಅದು ಬಹಳ ಶಾರ್ಟ್ ಇರ್ತಕ್ಕಂಥ ಒಂದು ಪೀರಿಯಡ್ ಆಗಿದ್ದು, ಅದರಲ್ಲಿ ಕೇವಲ 2 ಎಲಿಮೆಂಟ್ಗಳು ಕಂಡು ಬರ್ತಾವ. ಯಾವ್ಯಾವು? ಒಂದು ಹೈಡ್ರೋಜನ್, ಇನ್ನೊಂದು ಹೀಲಿಯಂ. ನೆಕ್ಸ್ಟ್, the electron filling of 1s orbital. Electron filling of 1s orbital takes place here. ಇದರರ್ಥ, students, when you write the electronic configuration of hydrogen and helium, you know atomic number of hydrogen is 1. Therefore, its electronic configuration is 1s1. Similarly, helium, its atomic number is 2. Is it right? Yes. Therefore, its electronic configuration is 1s2. It indicates here means in presence of first period, the electron filling of 1s orbital takes place. ಇದರಲ್ಲಿ 1s orbital ಏನಾಗ್ತವೆ? ಫಿಲ್ ಅಪ್ ಆಗ್ತಾವಂತ. ಎಲ್ಲೇ ಫಸ್ಟ್ ಪೀರಿಯಡ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬರೋದು ನೋಡಿದ್ರೆ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲಿ ಕೊನೆ ಆಗ್ತಾವಂತ ಒಂದೆಸ್ ಆರ್ಬಿಟಲ್. ಎಲೆಕ್ಟ್ರಾನ್ ವಿನ್ಯಾಸ ಗೊತ್ತದ ನಿಮಗೆ? ಅದರಲ್ಲಿ ಈಗ ನಾವು ಫಸ್ಟ್ ಪೀರಿಯಡ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬರೆದ್ರೆ ಅಲ್ಲಿ ಒಂದೆಸ್ ಆರ್ಬಿಟಲ್ ಫಿಲಪ್ ಆಗಿ ಕಂಡು ಬರ್ತದಂತ. ನೆಕ್ಸ್ಟ್ another one point, the corresponding principal quantum number n equal to 1. ಏನು ರಿಸಲ್ಟ್ ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಅಂತ ಇದ್ರ ಬಗ್ಗೆ ನೀವು ಚಾಪ್ಟರ್ ಕಲಿತೀರಿ. ಬಟ್ ಈಗ ಒಂದು ಜಸ್ಟ್ ಪಾಯಿಂಟ್ ನೆನಪಿಡ್ರಿ, ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಇಟ್ ಡಿಟರ್ಮೈನ್ಸ್ the period which the elements is belongs to. Remember students, principal quantum number is one of the number, it determines the period which the elements is belongs to. ಈ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಏನು ಮಾಡ್ತದ, ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಎಲಿಮೆಂಟ್ ಯಾವ ಪೀರಿಯಡ್ ಸಂಬಂಧಪಟ್ಟಿದ್ದಪ್ಪ ಅಂತ ತೋರಿಸ್ತಿರ್ತದೆ. ಈಗ ಹೈಡ್ರೋಜನ್ ಇಟ್ ಇಸ್ ರಿಲೇಟೆಡ್ ಟು ಫಸ್ಟ್ ಪೀರಿಯಡ್. ಅಂದ್ರೆ ಫಸ್ಟ್ ಪೀರಿಯಡ್ ಅಂತ ಏನ್ ಹೇಳ್ತಾ ಇದೆ, ಇದು ಒಂದೇ ಅದರದ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಏನದ, ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ 1 ಅದ. ಇಟ್ ಇಂಡಿಕೇಟ್ ಬೈ n ದಿ ನಂಬರ್. ಇದ್ರ ಬಗ್ಗೆ ಮುಂದೆ ಕಲಿತೀವಿ. ಬಟ್ ಈಗ ಸದ್ಯಕ್ಕೆ ತಿಳ್ಕೊಳ್ಳೋದೇನು, ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಅಂದ್ರೆ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಎಲಿಮೆಂಟ್ ಯಾವ ಒಂದು ಪೀರಿಯಡ್ ಸಂಬಂಧಪಟ್ಟಿದ್ದಂತ ತೋರಿಸ್ತಾ ಇರ್ತದೆ. ಎಸ್ ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ದಿಸ್ ಇಸ್ ರಿಲೇಟೆಡ್ ಟು ಫಸ್ಟ್ ಪೀರಿಯಡ್. It is one of the very short period containing only two elements. What are those? Hydrogen and helium. Here, one s orbital is filled by the electrons and corresponding principal quantum number is 1. Next, second period. You observe carefully the periodic table. Yes, in presence of second period, it is one of the short period. Means it is not a very short period, but it is also a short period containing 8 elements. From lithium to neon. Yes. Remember students, second period, it contains 2s and 2p orbital. Yes. It is one of the short period containing only 8 elements from lithium to neon, and the electron filling of these 2s and 2p orbitals takes place. 2s and 2p orbitals takes place. How? Students, when you observe the electronic configuration of lithium atomic number is 3. You know, electronic configuration is 1s2 2s1. Is it right? 1s ದಾಗ 2 electron, 2s ದಾಗ 1 electron. Total ಎಷ್ಟು electron? 3 electron. ಅದಕ್ಕಾಗಿ ಏನು ಹೇಳ್ತಾರೆ, in presence of second period, the electron filling of 2s and 2p orbitals takes place. When you observe the electronic configuration of neon, its atomic number is 10. At that time, the electrons, our electronic configuration is 10 on the other period. 1s2, 2s2, 2p, 6 are 10 to 10. Means here p orbitals are completely filled. Therefore, the electron filling of 2s to 2p orbitals takes place in second period. Next, the corresponding principal quantum number is n equal to 2 here. What is principal quantum number here? It determines the period which is related to particular element. Next, third period. just change here the points. Third period means here 3s 3p orbitals are observed. 3s and 3p orbitals. Okay, students, in that first point, in presence of third period, first point, it is also one of the short period. In ಮೂರನೇ period ಕೂಡ ಏನದ, it is also one of the short period containing 8 elements. ಇಲ್ಲಿ ಕೂಡ ಏನದವ, there are 8 elements from sodium to argon. Yes, remember, atomic number of sodium is 11 and argon is 18. Students, remember, third period, it is also one of the short period containing only 8 elements from sodium to argon. It is the first member of the period and it is the last member, argon. Next, the third period starts from sodium and it ends with argon. Remember, and the electron filling of 3s and 3p orbitals takes place here. 3s and 3p orbitals. When you write the electronic configuration of sodium, it ends with 3s orbital and argon, it ends with 3p orbital electrons. Okay, students. Next, the corresponding principal quantum number in presence of third period, it is n equal to 3. Now let's change ಮಾಡಿದ್ದೇನೆ. ಹೌದಾ? ನಿಮ್ಮ ನೋಟ್ಸ್ ಅಲ್ಲಿ ಸಪರೇಟ್ ಆಗಿ ಬರೆದು ನಾನು ಕಳಿಸಿದ್ದೇನೆ, ಅದನ್ನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. But remember the points, these are very important. In presence of third period, which type of orbitals are filled by electrons? 3s and 3p orbitals. Students, remember, first period is very short period because it contains only 2 elements. Second and third periods are short periods because they contain only 8 elements. Next, come to the point of fourth period. How many periods are present in periodic table? You already know there are 7 periods. Yes, fourth period. In presence of fourth period, there are 3 types of orbitals. One is 4s, 3d, 4p orbitals. So students, remember, it is one of the long period. It is one of the long period because it contains 18 elements. Yes, it contains 18 elements. Okay, and I write one more thing here. In presence of fourth period, first point is it is one of the long period containing 18 elements. This period start with which element? Potassium to krypton. Yes. Students, remember, fourth period is one of the long period containing 18 elements. ನಾಲ್ಕನೇ period ಅನ್ನು ನೋಡಿದಾಗ ನಮಗೆ ಅಲ್ಲಿ 18 ಎಲಿಮೆಂಟ್ಗಳ ಜೋಡಣೆ ಇರೋದು ಕಂಡು ಬರ್ತದೆ ನಾಲ್ಕನೇ period ಅಲ್ಲಿ. And this period starts with the potassium. Okay, potassium symbol is okay. ಈ ಪೊಟ್ಯಾಷಿಯಂ ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಮತ್ತೆ ಕ್ರಿಪ್ಟಾನ್ ಎಲಿಮೆಂಟ್ ಇಂದ ಎಂಡ್ ಆಗ್ತದೆ. ಯಾವುದಿದು? ಫೋರ್ತ್ ಪೀರಿಯಡ್. ಅಂಡ್ another one point, in presence of fourth period elements, the electron filling takes place in presence of 4s, 3d and 4p orbitals. 4p orbitals. Yes, ಈ ಒಂದು ಪೊಟ್ಯಾಷಿಯಂ ಉಂಟು ಮತ್ತು ಕ್ರಿಪ್ಟಾನ್ ಅದರ ಮಧ್ಯೆ ಇರ್ತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ನಾವು ಬರೀತಾ ಹೋದಾಗ ಅಂದ್ರೆ ಇವೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಯಾವ ಪೀರಿಯಡ್ ಸಂಬಂಧಪಟ್ಟಿದ್ದು ಫೋರ್ತ್ ಪೀರಿಯಡ್ ಸಂಬಂಧಪಟ್ಟಿದ್ದು ಅವುಗಳ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ವಿನ್ಯಾಸವನ್ನ ಬರೆದಾಗ ಅದು ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 4s ಆರ್ಬಿಟಲ್ ಆದವು ಅಥವಾ 3d ಆರ್ಬಿಟಲ್ ಅಥವಾ 4p ಆರ್ಬಿಟಲ್ ಎಂಡ್ ಆಗಿದ್ದು ಕಂಡು ಬರ್ತಾ ಇರ್ತದೆ. Yes, next one, the corresponding principal quantum number is n equal to 4 here. N equal to 4 in presence of fourth period. Next, similarly, fifth period. What is the changes here? Just observe. The next one, fifth period. In presence of fifth period, there are 5s, 4d and 5p orbitals are observed. Students, remember, fifth period is also one of the long period containing 18 elements. Even fifth period alli kuda namage 18 elements irodu ಕಂಡು ಬರ್ತದೆ. And this period is start with rubidium, to xenon. As I remember, students, in presence of fifth period, it starts from rubidium and ends with xenon. Periodic table ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ. ಈ ಒಂದು ಫಿಫ್ತ್ ಪೀರಿಯಡ್ ರುಬಿಡಿಯಂ ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ, xenon ಅಂತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ ಇಂದ ಎಂಡ್ ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್, the electron filling of, just I change the orbitals here because I mentioned already here, in presence of fifth period elements, the electron filling of 5s orbital, 4d orbitals and 5p orbitals takes place. When you observe the electronic configuration of particular elements which are present in fifth period, the electronic configuration is ends with the electrons containing 5s orbital or 4d orbitals or 5p orbitals. And another one, the corresponding principal quantum number is n equal to 5. n equal to 5 ಅನ್ನು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತಿರ್ತದೆ. ಈ ಒಂದು 5ನೇ ಪೀರಿಯಡ್ ಇಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್ ಒಂದೇ ಅದಾವ ಅಂತ ತೋರಿಸ್ತಿರ್ತದೆ. 5ನೇ ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ 5 ಇದು ಫಿಫ್ತ್ ಪೀರಿಯಡ್ ಅಂತೇಳಿ ತೋರಿಸ್ತಿರ್ತದೆ. ನೆಕ್ಸ್ಟ್, another sixth period, very important. Sixth period, which type of orbitals are involved here? Just observe. There are 6s, 4f, 5d, 6p. Yes, there are 4 type of orbitals. Students, but another one important point, it is one of the very long periods. Yes, sixth period as well as seventh period are very long period containing 32 elements. Yes, in presence of sixth period, I read the first point. It is one of the very long period containing 32 elements. Sixth period ಅಲ್ಲಿ ನೀವು ಟ್ಯಾಬ್ಲೆಟ್ ಕಾಲಮ್ 6ನೇ ಪೀರಿಯಡ್ ನೋಡ್ತಾ ಹೋದ್ರೆ ನಿಮಗೆ ಅಲ್ಲಿ 32 ಎಲಿಮೆಂಟ್ಸ್ ಕಂಡು ಬರ್ತಾವ. ಅದಕ್ಕಾಗಿ ನಾನು ಇಲ್ಲಿ ಬರ್ತೇನೆ, it is one of the long period containing 32 elements. Yes, this period starts with, means sixth period is start with cesium. Cesium-2 add-on. Yes, remember students, sixth period is start with the element cesium and ends with radon. And the electron filling of sixth period elements takes place with 6s, 4f, 5d and 6p orbitals. When you observe the electronic configuration of 6th period elements, the 6s, 4f, 5d or 6p orbitals, and the corresponding principal quantum number is n equal to 6 here. N equal to 6. Okay. Next, another type of period, that is last one, that is 7th period. In presence of 7th period, here 7s, 5f and 6d and 7p orbitals are observed here. Students, remember, it is one of the incomplete period. Remember, it is one of the incomplete period containing known 29 number of elements. Known 29 number of elements, but the maximum number of elements are also 32 here. Yes, ಏನು ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ ಈ ಒಂದು 7th period elements ಅಲ್ಲಿ maximum 32 elements ಇದಾವೆ. ಆದ್ರೆ ಅದರಲ್ಲಿ ಗೊತ್ತಿರುವಂತಹವು ಅವು ಗುಣಲಕ್ಷಣಗಳನ್ನ ಆಲ್ರೆಡಿ ಸ್ಟಡಿ ಮಾಡಿರತಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್ ಎಷ್ಟು ಬರ್ತಾವಲ್ಲೇ 29. 29. And remember students, the electron filling of which orbitals 7s, 5f, 6p and 7p orbitals are takes place here, and it starts with francium. Remember, it starts with the francium. And start with francium, and corresponding principal quantum number is here n equal to 7. Yes, this is about the classification of elements in a particular periods. Students, one more important thing, remember 6th period elements. Remember, 6th period elements are also called as lanthanides. 7th period elements are also called as actinides. These lanthanides and actinides are also called as inner transition elements. And these lanthanides and actinides are comes in place of F block elements. Okay, the detailed study of these particular block elements is studied in next class. Thank you.